Okay, so let's talk about scientific notation and practice problems. So our first problem is 2,400,000 micrograms. We need to put that in scientific notation, so we're going to move the decimal till there's one non-zero digit to the left. So it's going to be between the 2 and the 4. But we need to decide how many significant figures it has. So I'm going to say there's 2 significant figures because all of these zeros are not significant. Even though they're important, they're not significant for our answer because there is no decimal shown. So that's going to be 2.4 times 10, and how many times did we move the decimal place? 1, 2, 3, 4, 5, 6. So 2.4 times 10 to the 6, and our original number was greater than 1, so it has to be a positive exponent. 2.4 times 10 to the 6 micrograms. Okay, so now we go to number 8. Again, we're going to move that decimal until there's one non-zero digit to the left of it. That'll be 2.56. Again, those are our only significant figures because the zeros in front are leading zeros. That's not where my money is, right? So that's going to be 2.56 times 10, and then our exponent will be 1, 2, 3, and our original number is less than 1, so that'll be 2.56 times 10 to the minus 3 kilograms. Make sure you're doing your units. So let's put the next one into standard notation. So we know that it just has one significant figure because there is just one shown, and it is 10 to the negative 5. That means we need to move the decimal so that it's making a number smaller than 1. So it's going to have to go to the left, and it goes to the left 4 times. So 1, 2, 3, 4. We have 4 zeros, sorry. So that'll be 0.00007 kilometers. And then the last one, it is a positive exponent, so we're making the number bigger, and we're going to move that decimal 4 times, and that means we'll add 3 zeros, so it'll be 62,000 millimeters. So your turn to practice. You do these, and then in class we will confer and see how you did. And you'll do those practices as well. Okay, so your worksheet, your homework is page 21 and 22 in your packet. So let's move on. So which balance is the most accurate? It's going to be the one that has the most digits. So if we see here, it's really hard to see. There are 2 digits. This one has 3. This one has 5 maybe. But look at this one. This is some big bucks right here. So the more accurate a balance is, the more expensive it is going to be. So let's look at our mathematical operations when we're using significant figures. So when combining measurements with different degrees of accuracy and precision, the accuracy of the final answer can be no greater than the least accurate measurement. I think of it as, remember that game called Red Rover? We all stand in a line and hold hands and we call somebody over and they try to break through our arms. Maybe it was just in my old days. It's sort of like that. Our number is only going to be as strong as our least number of sig figs. So we're going to apply that to mathematical operations. A couple things to remember. Always remember your PEMDAS and always remember putting units. So we'll start with addition and subtraction. When you add and subtract, your answer cannot be more than the last significant place of the least accurate measurement. In other words, it's the least number of decimal places, and I will show you. So we have 3.75 and 4.1. At the beginning, it's easier if you stack them like we did when we were first learning how to add and subtract decimals. So you're stacking them over the decimal. We do the math first, no big deal. And then you look to see, well, 3.75 has 2 decimal places, and 4.1 has 1 decimal place. So we can only show our accuracy to 1 decimal place. So that means that when we look at the answer, 7.85, it can only have 2 decimal places, but then we look at the 5, and that 5 will make the 8 round. So that will be 7.9 milliliters. Let's look at this one. 224 grams and 130 grams. Well, there's no decimals, but we're looking at the digits. So we do the math first, 354, and we look to see where that last digit is. And that's where we're going to put the significant digit, and that's where we're going to put that line. So we know that our answer can only have two significant figures. That 4 is still important, but it doesn't need to be rounded. It's there for a placeholder, but it doesn't need to be rounded. So that's going to be 350 grams. Again, more practice with addition, subtraction. Notice how you were putting okay, well that one's in the wrong place. Evidently that got moved. It should be right here. The line should be right here. I'll fix it. So your answer should be 150.5. I don't know how that got moved. That was weird. Okay, this one's right. So again, the least number of decimal places. So we've got 2 decimal places here, 3 there. Our answer can only have 2 decimal places. When that 9 and then the 5 is going to make the 9 round, and so it's going to be 1.0. Okay, another example, and you can do this one on your own. Please write that down. Let's go on to multiplying and dividing. Got some weird stuff on there. So multiplying and dividing, it's going to be the least or the fewest number of sig figs is going to determine the number of sig figs in the answer. So we're multiplying this, no big deal, we just do the math. 13.91 grams per cubic centimeter times 23.3 cubic centimeters. Again, cubic centimeters are going to cancel, and we get 324.103. That's what the calculator gives us. We're not putting all those answers. So I look back here. I've got 4 sig figs in the first number, and I have 3 sig figs in the second number. So my answer can only have 3 sig figs. So that's going to be 324 grams. Least sig figs. Why? I'll just put these up. Well, so in the first example, again, we have 4 sig figs. We have 2 sig figs. Our answer can only be in 2 sig figs. So that's why we have to cut that off. That 9 is going to make the 3 round. So we have 2.4 grams per milliliter. Number 6, it's hard to see. It's going to be our least number of decimal places. That needs to be scooted over. So we can only have 1 decimal place. And so that is how we got 18.1, because that 6 is going to make that 0 round. Okay, so we're moving on. So when measurements are multiplied or divided, the answer can contain no more than significant figures than the least accurate measurement. Again, least number of sig figs when you have multiplication and division. We have 3 sig figs, so our answer has to be 3 sig figs. So you need to add these statements to your notes. Exact numbers do not limit the number of significant figures. So if we count them, like 12 students, those numbers do not affect our significant figures. Defined conversions, like 1 meter equals 100 centimeters, that does not limit our significant figures. And then note that when switching between addition, subtraction, and multiplication division rules, you need to round your answer before switching rules. And there's some practice problems. Okay, so here's your tips just at the very end. Determine which rule you're dealing with first. It's going to save you some grief. Again, addition, subtraction, least decimal places, multiplication, division, least number of sig figs. All right, so we are going to use a calculator in this class often. So I want to be able to show you what we're going to do. Hopefully. I don't know. I don't know if we'll be able to see this. We'll see. All right, so on your TI calculator, I'm not going to be able to see that. Well, let me see. Oh, there we go. All right, so we've got let me turn it on. Clear. 5.44. And to put in the exponent, we're not using a caret. We're not using times 10. Not. You're going to do the second key and then the EE key. It's the comma key that's right above the 7. And this E tells us that that is the exponent. It's a times 10, and it's waiting for you to put in the exponent. So in this case, it is a exponent of 7, then divided by 8.1. Again, there's an exponent, so that's going to be the second EE key, and the exponent is 4. We enter it, and this is what we get, right? So we need to figure out, we can't put all these numbers down as our answer. We just don't do that anymore, right? So we need to look back at our original numbers. We have 5.44, that was 3 sig figs. 8.1, that is 2 sig figs. This was multiplication or division, so the rule is least number of sig figs. So it can only be 2. So that's going to be 6.7, 6.7, but this 1 is not significant. It does not mean that it's not important. It just means it's not significant. So in that case, it would be 670 grams per mole. 670 grams per mole. You can put it in scientific notation. You don't need to for that. But 6.7 times 10 to the 2 grams per mole. When we're looking at direct proportions, we have direct and we have indirect or inverse. Direct on a graph is going to look like this, where you have that steady climbing in a positive manner going up to the right. An indirect relationship or proportion is going to show this J curve. It's going to be a curve like this. So it's an exponential curve, actually. And then you can review those concepts at the end, and that is the end. So we will now get together and we'll do some practice. We'll do the practice that was in your packet, and we'll do some more that are in your homework. I'll see you soon.